there's just a couple things I want to point out on the worksheet. And, first off, we're getting into this topic of sequences and series. And, they do mean different things, although they're very closely related. The sequence is a list of numbers. Might have a pattern, might not. Most of the ones we're going to look at in here have some kind of pattern. And we can write up this a sub n, which is known as the nth term or the general term of a sequence. Limits are going to become very interesting in this module as well, because what we're going to be looking at with sequences and series is whether or not they converge or diverge. A topic that we covered back with improper intervals, which are going to reappear next week as well. But that same concept: do the sequences go to a number? Do the series go to a number? Are they well behaved? Okay. So that's why the point of this worksheet is just to get you used to some of the terminology. If you have a common difference, it's arithmetic. A common ratio is geometric. And then 8.2 specifically focuses on what are called geometric series. So when we sum up the terms of a sequence, we get a series. And that's when we're going to start to see the summation notation. Now, I kind of threw it at you today because you haven't gone through the 8.2 lesson yet until now. But we're going to get a little bit of practice with this summation notation on Thursday. And hopefully by the end of Thursday, you start to feel really comfortable with it. And as you saw, you got the formulas in 8.2 to do a finite geometric series, which are A and B here. And it turns out we can do infinite geometric series if we have a common ratio between -1 and 1. So we're going to be picking up with the geometric series on Thursday. And because we've already gone through the worksheet, we're going to focus more on some applications of geometric series and make it really cool. And if we need to, we can look at the summation notation, because we're going to see a lot of summation notation in this module. Okay, so there's two things going on there, and they're both, we'll discuss them both. Oops. Convergent and bounded. Let's talk about, they're similar, but they're not the same. Okay, so a sequence is convergent if it goes to a single value. And right now, let's talk, because it's where we're going to head this module. We'll only talk about infinite sequences and series. So a sequence is convergent if it has a limit. In other words, if we can say, okay, the limit as n goes to infinity of a sub n equals some value. So to tell if something is convergent, really all we have to do is compute the limit. So let's look at an example of one that's in convergent and one that's not. So let's say our sequence is its general term is given as 1 over n. Then to determine if that is convergent, all we do is we take the limit and we treat it just like we would the limit of a function, which means, we can use things like L'Hopital's rule. We can use graphical methods. This is exactly the same kind of limits you were learning to calculate in Calc 1. Now, with a function like this, we have something where the denominator is growing, the numerator stays at 1. Or if we wanted to look at it graphically, it's this graph here. So as the inputs increase, we can see that the function goes down to 0. Because this limit exists, this would be considered a convergent sequence. So as far as identifying a convergent versus divergent sequence, It really is just a matter of calculating the limit. Now, it doesn't have to go to 0 for it to be convergent. Let's look at, for example, if we had limit as n goes to infinity of, let's just say n plus 1 over n minus 1. That equals 1. So the sequence given by n plus 1 over n minus 1 would be convergent. Now, we'll spend more time on Thursday and next week talking about how to identify where the series is convergent or divergent. So today we'll just talk about a sequence. So an example of a sequence that would be divergent is anything that the limit doesn't exist. So if we had our general term be, let's say, e to the n, well, we know that the limit as n goes to infinity of e to the n equals infinity, or doesn't exist because it doesn't go to a single value. So this would be an example of a divergent sequence. So for sequences, convergence and divergence really just comes from the limit. As n goes to infinity, does the sequence go to a finite value or not? If it does, it's convergent. If it doesn't, it's divergent. Now let's talk a little bit about, before we talk about bounded, questions about that idea. So conceptually, what's going on is we want to know if our sequence converges to a number. For instance, 1 over n, we have 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Those keep going up, 1 over 100, 1 over 1,000, 1 over 1,000,000. What's happening is those numbers are converging to 0. So that's basically what's going on. The way we can test it is with the limit. A bounded sequence, it means that the sequence is bounded somewhere, but it doesn't necessarily mean it's convergent. And it can be bounded on one side or it can be bounded on the other. One of the most common examples is a sequence that would be defined by sine. Because if we think about what's happening now this is a sequence, so it would just be points. And these would be our points being generated by our sine. So what we have is a sequence that is bounded on top and on bottom. It's bounded between -1 and 1. But if we take the limit as n goes to infinity of sine of n, well, that's a dne because it doesn't go to a finite value. It keeps oscillating. So this would be the example of a bounded sequence because its numbers, its values, its outputs never get bigger than 1 or never lower than -1, but it's not convergent. Our sequence here, 1 over n, is bounded below by 0, but it's not bounded above. So that's what's going on with convergence versus bounded. Think of bounded as being, a line that the sequence can't cross. Convergent means as n goes to infinity, our sequence of numbers is going to a particular number. Good question. We haven't talked about bounded functions in this course. We talked a little bit about convergence and divergence, and they are kind of related because a lot of times if we have a convergent sequence, just like 1 over n, it does converge at the same place that it's bounded. So that'll happen more often than not. but they're not the same thing. Bounded just tells us, hey, our sequence will never go above this or below this. And again, we could have a sequence that's only bounded on one side, could be bounded above, or it could be bounded below, or it could be bounded above and below. Convergence is going to be the much more powerful idea going forward, because that's going to be what we really care about. We care about convergence sequences, and as you're going to see on Thursday and next week, we're going to really focus on determining whether or not series are convergent or divergent.